So welcome to this latest video 162 Maths, and in this video we'll be going over the GCSE Maths higher topic of probability. Now as always, I'll include a copy of the questions that we go through in this video in the description below for you to have an attempt at before watching this video, which I strongly recommend you do to see how much you know. So let's get straight into this GCSE Maths higher probability audit, which covers some exam style questions. Now again, a reminder, a copy of the questions are available for you to download by clicking on the link in the description below. So looking at question 1, it says that a bag contains white beads, black beads and red beads. The following trial is repeated 100 times. So you pick a bead at random, record the colour, put the bead back in the bag, and the graph shows the relative frequency of a white bead after every 20 trials. And it says work out the number of times a white bead was picked in the first 20 trials. So for this, what we need to do is first of all find 20, which is just there, and then we're looking for the point at that particular point, which is just here. Now here the relative frequency is roughly about 2.5. So then all I then need to do to work out the frequency is do the number of trials times by the relative frequency, which is 0.25, and that gives me an answer of 5. Moving on to 1b, it says what is the best estimate for the probability of picking a white bead? Give a reason for your answer. Well, the best one is going to be the very last one, and the reason for that is because you've done it over multiple trials. So here the correct answer you want to write is going to be 0.32, and something along the lines of the more trials equals the more reliable probability. And something along those lines would be absolutely fine. Then moving on to 1c, it says there are a total of 1,000 beads in the bag. Estimate the number of beads that are white. So for this, all we need to do is do the best relative frequency, which is 0.32, multiply that by 1,000, and we get an answer of 320. Then moving on to question 2, it says A and B are independent events. It says fill in all 8 missing probabilities in the diagram below, and this, here we go. So remember that, so if the probability of A is 0.3, the probability of not A is going to be 0.7. Now looking at the fact that we've got the probability of A multiplied the probability of B equals 0.12, because they are independent, so we just multiply them. We know that A is 0.3, so then to work out the probability of B, it's going to be 0.12 divided by 0.3, which is 0.4. So that means the probability of getting a B is 0.4, and therefore the probability of not getting B is going to be 0.6. Then all that's left for me to then do is multiply. So here I've got 0.3 times 0.6, which is 0.18. For this one, we've got 0.7 times 0.4, which is 0.28, and 0.7 times 0.6, which is 0.42. So the 8 probabilities I'll just highlight on the screen. And again, do you have to show you working out for these? I'd say probably not. If you're writing down the correct probabilities, that should be good enough to get all the marks. Then moving on to question 3, let's just zoom in so we can see a little bit clearer on the screen. So it says a bag only contains black counters and white counters. A counter is chosen from the bag at random and replaced. Another counter is then chosen from the bag at random. The probability of choosing 2 black counters is 0.36. Show that the probability of choosing a black counter each time is 0.6. Well, here, if we're selecting the probability of a black multiplied by another black, it tells us that this is going to be equal to 0.36. Now I can rewrite this as the probability of B squared equals 0.36. So therefore the probability of a black is going to be the square root of 0.36, which is 0.6, which is what they wanted me to show. It then says work out probability of choosing 2 white counters. Well, the probability of a white counter is going to be 1 minus the probability of a black counter. So that's going to be 1 minus 0.6, which is 0.4. So then the probability of a white and a probability of another white is going to be 0.4 multiplied by 0.4, which equals 0.16. Then moving on to question 3C, it says work out the probability of choosing at least one white counter. Well, for this there are several combinations we could do, but for this particular question, for 2 marks, we need to try and think simple. So here the probability of at least one white is going to be equal to the probability of all black. Now we already know that the probability of the 2 counters being black is 0.36. So therefore the probability of it being at least one white is going to be 1 take away 0.36, which is 0.64. Then moving on to question 4, it says 2 bags A and B contain beads. Bag A contains 7 beads and 2 yellow beads. Bag B contains 1 red bead and 4 yellow beads. 1 bead is taken at random from a bag A and put into bag B. 1 bag is then taken at random from bag B and put back into bag A. Work out the probability that bag A still contains exactly 7 beads. So for this, let's just start by drawing a tree diagram. So we've got bag A and we've got bag B. So then from this, we can either go for red and yellow. And then from this, we've got red and yellow, red and yellow. Let me just move that bag A label a little bit higher. So from this, to start off with, we've got a total of 9 beads in bag A. And out of those 9, 7 are red and 2 are yellow. Now if I select a red one from bag A and put it into bag B, then I'm going to have a total of 2 red beads, and if there were 5 altogether and I've put 1 from A to B, there's therefore going to be 6 beads altogether. So from this, if there's 2 out of 6 that are red, then 4 out of 6 are going to be yellow. Then if I've selected a yellow bead from bag A and put it into bag B, and they're also going to have 6 beads. And if I've already put a yellow one, then I'm going to have 1 red one, and I'm going to have 5 yellow. Now from this, what we're then going to do is we're then going to put this back into bag A. Now for the red ones, now if I've gone for this route, originally in terms of the red, I've got 6. And then if I'm then going to put 1 in from bag B back into bag A, I'm going to have 6 plus 1, which is 7. If I've selected a red one, I put that in bag B, then I pick a yellow one, then I'm going to put a yellow one back into into bag A, so that's going to be 6 plus 0. So there's going to be 6 red counters in bag A when I put that counter from bag B into bag A. Then if I pick a yellow one, then a red one, then I'm going to put that means I've got 7, and I'm putting another red one, which is going to be 1, so that's going to be 8 red beads in bag A at the end. And if I've selected a yellow one and then another yellow one, then I'm still going to end up with 7 red beads back in the bag. So the possible outcomes are going to be either this one here or this one here. So the probability of having 7 in bag A at the end is going to be if I pick a red and a red, or a yellow and a yellow. So then working out these 2 probabilities, I'm going to have 7 over 9 times 2 over 6. All means plus, and then yellow is 2 over 9 times 5 over 6. And if I type that all into my calculator correctly or work it out, I'll end up with 14 over 54 plus 10 over 54, which gives me a total of 24 over 54, or I can simplify that to 12 over 27, which simplifies further to 4 over 9. Then moving on to question 5, it says that a school has 86 teachers, 42 are male and 44 are female. A third of the male teachers have blue eyes, a quarter of the female teachers have blue eyes, and the question is asking us to complete this Venn diagram. So let's first of all work out what each of the sections are going to be. So this section here is, and I'll do my best to color code it. So this region here are non-males, in other words females, with blue eyes. This region here are males with blue eyes. And this region here are males without blue eyes, and this outside region is going to be females without blue eyes. So that's each of the sections of this particular Venn diagram. Now we know that the males needs to add up to 42. So here, if a third of 42 is going to be 42 divided by 3, which gives me an answer of 14. So that means that 14 is going to be in the middle. So let me just write number 1 there. Then working with number 2. So here we've got a quarter of the female teachers. So a quarter of 44, which is 11. So that means that this section here is going to be 11. Let's just write number 2. Then working out this region here, so let's call that number 3. Well, we know that all of that circle of M needs to add up to 42. So then if I then do 42 minus 14, I get an answer of 28. So that's going to be 28. And then looking at the total, well, that's going to be 42 plus 44, which is 86. So then to work out this outside number, do 86, take away 28, take away 14, take away 11, which leaves me with an answer of 33. So if I just write number 4 there, and there I've completed this Venn diagram. And then moving on to question 5, it says one teacher who has blue eyes is chosen at random. Work out the probability that teacher is male. Well, for them to have blue eyes, it basically means that they've got to be in this circle. Now in the circle of that I've just highlighted, there are 25 in total. And out of that 25, how many of those are male? Well, it's going to be 14. And so my final answer is then 14 over 25. Or you could write it as a decimal, which would be 0.56. So whichever of those answers floats your boat will be absolutely fine.